Yeah.
Okay, I want to get you guys to the lab working on finishing up 5.2 first. Well, we've got assignments up from 5.2 through 5.4. I do want to, real quickly though, take a look at a couple of the problems like the ones at the end of 5.2. Sounds like those are the ones people are having maybe the most trouble with. Okay, this one here is, I want to show you that this one is your friend. It's easy. We always want to, when we're faced with a quadratic equation like this, m's our variable instead of x this time, but, you know, same thing. What's our first step always? Is there a single m that I can point to and isolate?
Yes.
There is?
No.
No. I've got two m terms that won't combine, right? I've got an m squared and an m, so I can't do my nice trick where I work backwards through order of operations and isolate m. I'm stuck. So now let's go through the steps here.
Would the young gentleman that is a new student at Pendleton High School please come to the office? I spoke with a young gentleman this morning that was a new student. Please come to the office. Thank you.
All right. There you go. So what do we do in this situation then if we can't point to a single variable that can be isolated?
Solve for the zeros.
We've got to find the zeros. But what do we have to do to the equation first then in order to do that?
On the other side.
Say it again. Well, we can't unsquare it here because I've got this other m, right?
25 m.
Okay, I've got to put it in standard form, right? I'm going to have to use my other strategy, which is if I can't isolate, I've got to factor the thing. I've got to put it into standard form where it's set equal to 0, break it apart into small factors, and then find the zeros of those small factors, right? So the first step here, and this is the one that's, once you get this, you're on the road. We're going to subtract 25m from both sides and get 5m squared minus 25m equals 0. Okay, now we got to get it equal to 0 because remember, ultimately our trick is that zero product property. We want to break this thing apart into a product of small factors that equals 0, and then by the zero product property, the product of these two factors can only equal 0 when the individual factors equal 0. Because the only way we can multiply stuff to get 0 is when we're multiplying by 0, right? Now, how do we factor this? And there's a tendency for people to want to skip right up to the hard stuff here. They want to try to think about this in terms of A times C, then split B, and do all that hard stuff. But don't skip over, even though it doesn't work all the time, or maybe even that often. What do we always want to try first when we're factoring?
The
Greatest common factor. We want to see what's the biggest thing that we can divide out of each term.
5.
And the biggest number in this case is what?
5.
5. But even more important than that, look at the variables. Each of the terms has an m. This is what makes this problem so easy. You're going to love these guys because you don't have the factoring is so simple. How many m's could I pull away from each term?
1.
Just m to the first power, right? Because that's all that this second term has to offer is m to the first power. But factoring means dividing. I can divide away a 5 and I can divide away an m. Now, if I divide those things away, same thing as undistributing. What am I left with from this first term? Well, 5 divided by 5 is 1. M squared divided by m is m. So that first term gives me an m. What about the second term?
-5.
25 divided by 5 is 5. M divided by m is 1. So the m's cancel, right? See that? Now look how simple that is. We got these two factors. We're going to find the zeros of these two factors, but this first one is a piece of cake. Whenever I get a variable by itself like that, where it's not added or subtracted to something, what's going to be the zero of that factor? What value of m is going to make that first factor equal to 0?
-1.
No. 0. Sure. Sure. Right? And we could do the math. If we want to set this equal to 0, I could divide both sides by 5, and I get m equals 0 divided by 5, which is 0, of course, right? But it's even easier than that, because you could just ask yourself, what value of m would I have to plug in to make 5 times m equal 0? Well, 0, right? So there's one of my zeros, one of my solutions to the equation. And then the other one, pretty simple, what's this one?
5.
Good. Okay? So don't skip that first step. Now we've got to put it in standard form before we do anything. Then you always try to factor out a greatest common factor. If you can factor out a variable, that's awesome. And that makes life really easy. Okay? All right, real quick, let's look at one like this. That looks terrible, right? Looks terrible, but it's not that big a deal. Now, what would I do if I wanted to solve this one? I mean, there's some work here involved.
Distribute.
Yeah, I've just got it looks like a mess, but all I've really got to do is just FOIL this guy out, right? And then distribute the 3 and add up like terms, and that's that. Okay? So what if we do that? What if let's take care of this part first. Now, if I'm going to FOIL out w plus 6 squared, what's that give us? First term's going to be w squared. Now let's combine the middle two. 6w, 12w, good total.
Plus 36.
Yeah. And then we've got our equals. If I distribute the 3,
Plus 36.
okay, and then minus w squared. Now what?
Combine like terms.
Combine like terms. We're going to push everything over maybe to the left side. So we get a positive number of w squareds. So put it into standard form. So I'm going to add w squared. It's going to give me 2w squared. I'm going to subtract 3w, right? And let's see, oh, look at that, the 36s cancel. Okay, that's nice. And then I've gotten everything, did I get rid of it all? I did, didn't I? All that stuff got moved over to the other side. So it's all equal to 0. Well, that's an easy one, isn't it? Right? I can't isolate w, but I can factor out a greatest common factor that includes w. In fact, what is my greatest common factor? W, sure. What's left over if I divided w away from each term?
2w.
Plus
9.
9. Okay, now we find the zeros. Well, when does the first factor equal 0? When w is
0.
0. And we can do this one in our head. If I set that one equal to 0 and solve for w, I'm going to get what? Negative 9 to... Going to subtract 9 to the other side and then divide by 2. Everybody see that? Okay. All right, and then the last one, let's take a quick look at. Write in intercept form and give the functions zeros. This sounds kind of tricky, but what are we really doing here?
The same thing we just did.
Yeah, intercept form, we talked about intercept form in 5.1, but you might recall that at the time I said it's really just factored form. That's all it is, right? We're just going to factor this thing, and then that puts it into intercept form. The x-intercepts, we can now see, are nothing more than the solutions of this equation, right? They're just the zeros. So if we factor this, let's see, what could we do? Now, one thing I would do here, one little trick. Let's factor out a negative 1. Okay. So then we're left with x squared minus 16x plus 64. So we've got this negative 1 out front, and then we'll just break apart everything inside the brackets. Okay, now what are two numbers? The two magic numbers here have to multiply to what? And add to negative 16, right? So what would those be? You got the right values. What about the signs?
Negative.
Negative and negative. Good. So x minus, whoops, not 6. X minus 8 and x minus 8, and then negative 1 times that whole quantity, right? So that looks like intercept form, doesn't it? A is negative 1. I've got my x-intercepts at the same places They're both at 8, which must mean that this parabola is just barely touching the x-axis at positive 8, huh? Right? Make sense? Okay. So the zeros are, there's only one of them at 8. Make sense? Okay. All right, let's go. 205.